All right, today we're going to look at the process of factoring polynomials, spend a little time reviewing what you learned in Algebra 2 Part 1, and the first warning as you do that, always begin by writing the polynomial in descending order, which again, remember, means the highest ordered term first down to the least, which is usually the constant. Step 1, factor out the greatest common factor. So here's an example. For the polynomial 3x plus 2, note it's in descending order, x to the first in the first term, and x to the 0, which we don't write, in the second term. So to accomplish step 1, if it's possible, we want to look for the greatest factor that is common to both the term 3x, right here, and 12 here. And so, probably obvious on this example that that would be 3. Okay, so we show that we factored out the 3 with this first 3 here, and then a set of parentheses showing we're going to factor that 3 out of both of these terms, respectively. So, in effect, you're really dividing 3x by 3, leaving x, and then dividing 12 by 3, leaving 4. And if you were to do the process of distributing over on the right side of this equation, you would clearly get to the left side. So you know you're accurate there. The question is this complete? Is this done? And so when you look now at the 3 and the x plus 4, those are two factors. There's nothing they have in common. So within each of those, can you take it any further? And since x and 4 have no common factors, this one is considered done. When the power is higher, it's a little bit more difficult to know when you're done, but just when we go through the steps, you always want to start with step 1 and then work to step 2, 3, 4, so on. Okay, step 2 is basically, again, after you've done step 1, check for a difference of squares. You may have several factors to look at, but in the pattern you'll discover it's a squared, some base squared, minus b squared, another base squared. And from Algebra 1 you might remember that that always factors to the base 1 plus base 2 times base 1 minus base 2. So these are pretty easy to spot because there will only be two terms within the factor to look for. And then when you're done you have two binomials, one positive and one negative, as you see here. Okay, so here's an example, 4m squared minus 49. Again, I didn't write the directions here, but usually you're just going to see factor. So always start with step 1. Is there a number that will go into 4m squared and into negative 49? In this particular case, the only answer there is 1, so that doesn't do us any good. So we'd move on to step 2, check for a difference of squares. There are usually 3 questions that I will try to have you ask yourself as you go, and if you get a no answer to any of them, stop and go on to the next step. The first question is, are there 2 terms only? And as you can see here, yes. Second question is, are they both squares? This can be a little bit tougher to spot, but certainly when you look at 4m squared, you can see the 4 is a square, and m to the second power, that's an even exponent, that's a square. And over on the other term, 49 is also a perfect square. And so yes, both terms are squares. The third question then is only one of those terms negative? And yes, negative 49 here is the only one. So if those answers are yes to each of the 3 questions, then you know it will factor, and I'll show you next what that looks like. Okay, so with a little bit of thought, you look at the first term here, that is 2m times 2m, or 2m squared, gives you 4m squared. For the second term over here, negative 49, that is 7 times 7, so 7 squared. So the base of the first term is 2m, the base of the second term is 7. Alright, so again now, take that first base plus second base times first base minus second base. Again, a common habit for some students here is you get to this point and you want to multiply this all back out using the FOIL process, which will take you right back from here to 4m squared minus 49. We don't want to do that. The job here was factor it. We now have 2 factors, 2m plus 7 and 2m minus 7. The only thing to check is there any common factor within each of these factors? And again, 2 and 7 don't share any common factors other than 1, and certainly there's only m's in each of the first terms, so no other common factors, and you'd be ready to move on to step 3. Alright, this third step, check for perfect square trinomials. You'll see a 3-term polynomial where the first term and the third term are perfect squares, and the middle term is actually twice or the opposite of twice the product of the bases. This one actually I'm not going to spend time on here because if you miss it with this step, you'll always catch it with step 4 anyway. So we'll move right into step 4. Okay, so step 4, we're going to factor polynomials with 3 terms again, where they have the form ax squared plus bx plus c. I'm going to switch over now and do this in my handwriting, so I apologize for the slop, but it's a little easier to see. There's really 2 cases, and our favorite case is if a is 1. Okay, so if that was the case, you may have a polynomial like x squared plus 5x plus 6. Okay, you can clearly see here that a is 1, b is 5, and c is 6. Okay, so if a is 1, it's pretty simple. You're looking for 2 factors, k and m, of c, so that k times m equals c, as you see right here. K times m equals c. But at the same time, you're looking for the pair of factors of c that will add k plus m to the b term. So for this problem up here, we're looking for 2 numbers that multiply to 6 but add to 5. Now you can list the factors in order to see this a little bit better. 6 has the factors of 1 and 6, or 2 and 3, sorry. Okay, so between those pairs, there are no other factors of 6. It's pretty obvious which 2 add to 5. Okay, and so we're going to be using the 2 and the 3. Now, here's where it gets interesting. Since a was 1, it will then factor, if I can get this to write down here and fit it, 2x plus 2 is one factor, and x plus 3 is the other factor. Not very neat, but again, if you were to FOIL this out, you would see easily with the first, x times x is your x squared, right here. X times 3 is 3x, then that's your outer pair, then your inner pair is 2 times x. So we have 3x out here and 2x in here. 3x plus 2x makes 5x, and then your last 2 times 3 makes 6. Okay, so here is another 3-term polynomial. We go through the steps. Step 1, common factors, none other than 1. Step 2, 2 terms only, no, so we don't even answer the other 2 questions. Move on to step 3 and see if we have a perfect square trinomial. As I said, step 4 will catch it anyway. It is not a perfect square trinomial anyway because 5 and 3m squared are not perfect squares. So we move right on to step 4 of the form ax squared plus bx plus c. Well, now our x is m, our a is 3, b is 16, c is 5. Obviously a is not 1, it's 3. So this gets a little bit trickier, but if you remember FOIL, this becomes your best friend. What you need to do then, in this particular case, is what you'll want to do is find the 2 factors of a, h and l, and 2 factors of c, k and m. When you have those factors, then remembering FOIL becomes your best friend because firsts, outside, inside, last. So we're going to have h and l, which are firsts. We have k and m, which will be our lasts. So we're going to look for the outer pair, h and m will go together. Those are our outers, as you can see here, here. And then our inners, L and K, need to go together. And when you add these together, then you're going to get your B. Okay? So it's hard to picture perhaps at first, but when you see these numbers, I think it'll make a lot more sense. So first thing is, come back up here. Let's find 2 factors of our A, 3. The nice thing here is 3 is prime, and so the only factors of a prime number are 1 and that number. And then we go over here to the C, 5. It's also prime. So finding its two factors is going to be pretty easy, 5 and 1. So we have our k and our m. We mark it here. And we have our our h and our l over here. Now our job is just to figure out which outer pair and inner pair, if any, produces the 16 up here, the b term. Okay? So as they're listed, our outer pair is 1 and 5. 1 times 5 is 5. 3 times 1, the inner pair is 3. 5 and 3 only gives us 8. We need 16. So what we want to do is reverse one of these. I'll switch the second pair here, and just for reference, cross those out. Now let's try our outer and inner pair. Okay, so our outer pair now is 1 with 1, that's 1. 3 with 5, 3 times 5 is 15, and 1 and 15 makes 16. Okay, now I'm going to have to cram in my space here, but I'm going to try to do this so you can see it. When you know that the firsts are 1 and 3, and the lasts, if you will, are 5 and 1, when you write your parentheses, let's see if I can fit it right down here in the lower left, parenthesis, parenthesis, okay? Make sure your firsts go in the first position of each parenthesis. So we had 1 and 3, 1 and 3, and it isn't necessary to write the 1, but I want you to see it here. And our first term up top here was m squared, so we know that's going to be 1m. Could have just written m there, and 3m. Okay, now our lasts were 5 and 1, and they are in order, so you got to make sure you put the first last, 5, in the first polynomial. So if I can make that work. They're all positive here, so everything's positive. And the second last, if you will, was 1. Okay, something you should always get in the habit of doing once you've factored here is do a quick FOIL and make sure that you get the polynomial that you wanted up top. So let's run through that real fast. 1m times 3m, that's 3m squared. Got our first term good. Then our outer pair, 1m and 1, that makes m. 5 times 3m is 15m. Those are like terms, so we have m plus 15m for a total of 16m. We're safe there. And then our last give us 5 times 1, 5, the proper c. So we have factored this correctly. And again, just double check that you don't have any common factors between 1m and 5, none, and 3m and 1, also none, other than 1, which is useless to us. Okay, on step 5, again, remember to start with step 1, step 2, step 3, step 4. Okay, now you're to step 5. There again are a sequence of questions that you can ask. This is called factoring by grouping. It will not always work, but it's worth a check. It may speed you up. Okay, usually you're going to see 4 terms for this. You might see 6, 8, but usually it's going to be 4 for us. And you just want to know when you see that to check. Make sure it's in descending order, and we're going to group the first 2 terms together and then the second 2 terms together and see if we can come up with anything in common. So here would be an example. If you look at step 1, it looks like there's m's in each term, but not over here at the last term. It looks like 3 would go into each term, but not here in the second term. We go to step 2. Are there 2 squares, 2 terms only? No. So we go to step 3, 3 terms only? No. So we're all automatically down to step 5 here. There's no way any of the other patterns will work because there's 4 terms. So what you're trying to do, it's in descending order, 3, 2, 1, 0. So group the first 2 together and the second 2 terms together. And what we want to do is try to find the greatest common factor of each one. So just focus on the first 2 over here and ask yourself, what is the biggest thing that goes into both of those terms? With a little bit of studying, you should be able to see that m squared, 2 factors of m, is the only thing that will go into both terms. So we're going to factor that out. M squared. And remember, when we factor it out, we got to show that it's out and show what's left. To get 3m cubed from m squared, we would need another 3m. And to get m squared from m squared, you need a 1. But notice it's negative, so we're going to have minus 1 here. Okay, so we just factored the first group. Okay, now we look at the second group, 9m minus 3, and we want to see if anything will go into both of those. 9 and 3 share the common factor of 3. Okay, and one thing that students often do is what I had just started to do here. This plus sign that you see up here should carry down to right here. So we want to make sure we write that in, or we might think we're multiplying here. We're not. We're still adding these next terms. Okay, so the 3 comes out of 9m, leaving 3m, and the 3 comes out of the negative 3, leaving negative 1. Okay, now how do you know if this process did you any good? Well, hopefully if you're observant, you will see the same common factor now in the first group and the same 3m minus 1 in the second group. So we just created two separate sets of factors with the common factor. Okay, so these are like terms. Now, just as a quick example, if you had, I'll go over, oops, need my writer, 2x plus 3x, everybody knows that that would be 5x. The question is, how did we get that? Okay, we would go to the final here of 5x. Yes, we would skip this middle term normally, but this is what you're doing. You're really factoring out the common factor of x and leaving the 2 and the 3 as the like terms. 2 plus 3 comes together to give you the 5. So we want to do that same procedure up here with our other problem. We have 3m minus 1s and more 3m minus 1s. One thing you remember when you're adding apples to apples, we always say you're going to get more apples. So we don't want to change it to 3m minus 1 squared, but what we do is, just like we did here, add the coefficients, okay, the numbers that were in front. Well, this time we have a variable here too, but so we have m squared and plus 3. Those are not like terms, so we just add them as best we can algebraically, which is m squared plus 3. Put it in parentheses, and there is the answer to factoring up above. 3m cubed minus m squared plus 9m minus 3. Finally, though, remember to always check to see if you have any other common factors. Quick visual here. Nothing works. So that is the practice that we're going to look at for today. Hope this helps you tackle the problems on your assignment quickly and efficiently.